Wonderful. Thank you again. Okay. So what I'd like to do now is go to Jeremy and Mark if they're available. Let me see if they are. We have Jeremy and Mark, Jeremiah Pop, Jeremy Reese. Jeremy Reese, sir, are you with us?
I would also love to see what's going on in that New Jersey lab right now. Looks like they're pretty busy on the.
Yeah, that was my hope, actually. That was my hope, because we're way ahead of schedule. So I would love to kind of see what they're doing. Maybe they can give us a rundown on it. When Nick Cook arrives, I would be, happy to put him on early. But until then, we got to fill a little bit of time. So.
I'm gonna call his cell phone. Unless he's using it to broadcast. I hope he's not.
Hey, if you could just go to Brenda, that would be Brenda's mic is she's got the camera on too. So
Okay. You want to go to okay. Brenda, are you there? Let me ask you to unmute.
Yeah, we got it.
There we go.
there we go. So we're right here at the lab, guys. Brenda's here and we're on her laptop. I can't get the audio working on my computer for some reason. There's some issue with Zoom and the camera, but anyone have a question? Because there's a delay. We have it broadcasting on the room behind us. You guys are repairing this transformer?
We're attempting to.
Okay, well, yeah, could you kind of give us a rundown of what you're doing, and maybe you could tell us a little bit about what you're planning to
Let's take
showcase
this
later.
as a little tour. We're here at the live meetup for the Alternative Energy Propulsion APEC conference for the 1-year anniversary. We have a camera crew here. We have a whole bunch of new tables and equipment that we got set up with lab stuff. I'm broadcasting right there. So did you shut that audio off?
Now, Jeremy, do you think you could tell us? So this is actually a 3-day event. You guys have been doing this since yesterday.
No audio,
right?
once again. Hold on, I might have audio. You guys must have done something on. Did you guys touch something on my computer? No, that's fine. Yeah, you can't do that.
Just so you know, when you get close
Yeah,
to
they turned off the
computer,
audio
you get
for
that
them
reverb,
too.
Jeremy.
I can't. I'm having technical difficulties here, guys. Sorry, I'm gonna have to mute the mic. I can't.
Okay, and that's fine. So are you able to hear us at all, or? Okay, looks like he's muted out. Jeremiah, you had kind of a question. Do you guys want to do kind of an open? Oh, he can hear. Okay, good. We'll give him just a sec, and then we can go to open discussion after that. And again,
sorry, can I just say something? Jeremy,
yeah, go for it, Remy.
Hi, Jeremy. Yeah, thanks, Tim. If you try audio settings, I think it's got suppress background noise. So if you go to in the bottom where it says they've got the microphone symbol in the bottom left, if you click on that, you'll bring up audio settings at the bottom of the pop-up, and you should see where you've got audio. You should see suppress background noise. Okay.
Thanks,
right.
Remy.
Give it a go. Yeah, that's all right. Give it a go. Yep. Okay.
Okay, yeah, it looks like his mic is still off, and I probably deserve this for going to them before they were ready. But Jeremiah, you had some stuff that you were going to mention also, right?
Yeah, and I'm not going to go on video. I'm thinking because I don't have the test set up really set up. I've kind of got it crudely set up. I wish I could just send a bunch of pictures here, but I don't have them on my computer yet, and I'm streaming from my computer. So that'll have to wait until I actually have a presentation put together. But right now we are testing the Morton effect thruster and the Morton effect pulse beam that's supposed to come from the thruster when you stationarily mount it. Then we're building a new AC pulse power supply that's going to ride on a 100 kV DC source. So that'll give us about 15 kV of AC modulation at nice impulse. Very fast rise time over about 100 nanoseconds, which is not ideal. It's not quite as quick as I'd like, but it's fast enough. And then, of course, the warp drive stuff and PNN's replication are just about ready, but they're not ready today. So I'm hoping next APEC to have some tests that I can demonstrate here. I was thinking about doing it today, but the prior DNO measurements did not end up producing positive results. It turns out to be scale drift. So no reason to show a null result again.
Okay. So actually what I'm going to do is, while we are trying to figure this out, I'm going to do a screen share. One of the things that we've been working on, and let me share my window here. Okay, so hopefully you guys can see that's our website, right? altpropulsion.com. So I would say a couple of weeks ago, we started testing different chat forums, right? We added 3 channels for WhatsApp, and we added a Discord channel, and we added a discussion forum as well. So I moved those over early last week to the contact page. Again, we have APEC 24/7, theory, and builders, right? So the 24/7 is just general discussion chat. And then the theory and the builders are kind of focused areas, because we have a lot of people in those groups. We've got like 80 something people in those groups. So, you know, it just helps keep things in the rails. The long form discussion forum is through a place called Tapatalk. And I want to thank Phil Bouchard for helping us get set up with that. So this is one where it is slowly starting to grow. We've got, you know, several posts there. Again, Phil has been posting pretty diligently on it, and he's getting a lot of views as well, which is wonderful. And then let me see, the live Zoom seminars, which you know about. The Discord channel, I actually just brought that up here. So Discord, one of the challenges that we had was trying to find basically an open public chat forum that let us kind of group things by topic, right? And so in something like Telegram or even the WhatsApp channels, you really can't use hashtags easily for that. So we ended up with Discord, and I don't know, it rubs some people the wrong way. Discord was developed for gamers. It does feel a little childlike in some ways, I guess. So we've tried to kind of modify it, make it a little bit more age appropriate for our audience. And so we actually have a lot of people signing up for it, and it's starting to get active. So those are our major channels. We also have Alt Propulsion on Reddit and the APEC Facebook group, right? And those actually haven't seen that much use yet. But, you know, so my thought would be, for discussions and ideas and anything along those lines, again, hit the contact page on our website. You can sign up for any of these. These are all open, they're all free. You know, and the goal is just to help foster discussion, sharing, and solving problems. So that's kind of what I have there for that. I could also show you really quick too. This has been kind of a pet project of mine. So one of the things that I did was, let me see. Okay, so the first thing I did was I rebuilt all of these pages. This is just a regular page on the Alt Propulsion website. You can see that we have the speakers listed down the middle. And then I redid the fonts. I tried to make it a little bit easier to read and try to make it flow better. Get the stuff there on the right. Now I'm going to play this on YouTube, but I'm going to turn the video off. The other thing that I did was, with these videos in the past, we have split these up, and I'm going to continue doing that for the time being for another channel. But I rendered this as 4K, and you can see that it has chapters in it now. And so that should make it a little bit easier to share things. If you want to share a specific part, you can right click on it and do copy URL at current time, you know, that, or you can always go to the American Anti-Gravity channel. I've got them split up there. It takes me close to a day to process each one of these videos. So, you know, but hey, it's worth it. It's worth it. Okay, so I think that was everything that I had to show you guys. So let me do a stop share there, and let me go back to Jeremy Reese now and see where he's at. Okay, Jeremy. Okay. I'll go to gallery view for just a sec. Guys, we can do you want to just do open discussion for a bit? Again, I should apologize for being so far ahead of schedule, you know, or if you want, if anybody wants, we could take a break. You guys could, you know, go and do whatever and come back in a bit. Looks like we have about 40 minutes until Nick Cook is scheduled to arrive. Let me see, Gene had asked some questions about. Gene, you had a question about symposiums dedicated to investigating frame dragging. Do you want to ask that? And do you think I can get your camera? Could you turn your camera on if that's okay? Oops. It looks like he might be having technical issues. Well, I would say, anybody have any topics that you want to discuss? Anybody have anything to bring up? Mikhail, would you like to go, sir? Oh, lots of them. Okay. Mikhail, do you want to go?
Yeah, sure.
Okay.
Thank you.
And if I could get you to turn your camera on too, sir.
Yeah, sure. I'm facing a bit of a network problem with bandwidth, so that's the reason. I just had one quick question to Shreehari sir itself. You know, the Vimanas, in terms of their design, have in your lab, I think your colleagues or so forth, are they collaborated with any defense establishment in India? Because I came across one research just day before yesterday. I was speaking to some nuclear scientists, and they were talking about the Vimanas reverse engineering program. So I just wanted to check with you. Did you ever? I mean, not you. I would say your entire team. Are they doing any research in terms of collaborating with the defense industry in India, in Russia, and in US or anywhere else in the world? Thank you.
Yeah, I can ask Shreehari if he's open to talking.
Okay.
Yeah, because I think he is still with us.
Yes, sorry.
Oh, absolutely. Only if you want to, sir. Only if you want to.
Yeah, okay. So yes, actually, I cannot disclose in detail, but yes, the team is working, and since many years actually, Shastriji and other team, they are working with defense, and a lot many devices are invented. So the answer is yes.
Awesome. Thank you. Okay, so let me go. Sam, you had a topic to discuss, and again, we're kind of past the Q&A session. So. Oop,
yeah, I'll just like just a general conversation piece.
Oh yeah, go for it, man. Go for it.
So like for the hieroglyphic that was shown earlier, it looked like a helicopter, a submarine, and like some UFOs, but isn't that kind of weird? Like, aren't helicopters and submarines hilariously outclassed compared to the physics bending of a UFO? I mean, why even put a submarine next to a UFO if you're trying to record technology? You all have any thoughts on that?
Well, I'm not sure what you're saying. You mean in the photos, right? Is that what you're asking?
Yeah, well, just in general, like
A
if
helicopter
you
is like a
stumble-
like a single dimensional
Yeah.
technology, and UFOs are like third or fourth dimensional physics. Is
Yeah,
what
like
you're
what is a
talking
sub
about, right?
going next to a
Well,
flying tic tac?
I would say a Tic Tac and the submarine look similar.
Actually, they kind of do, don't they? They kind of do.
So and it basically what it is. I would call it is a multimedia transit device.
Yeah, well, and they both look like propane tanks also, but they're pressure vessels, right? So maybe that's the most efficient form for a pressure vessel.
Well, if you have that, then why even bother with a helicopter or a submarine? Wouldn't that just outclass them?
Yeah, you would
Well,
think so, but
Or are
we don't know.
submarines
That's a
more
good
evolved
question.
UFOs or less evolved UFOs? And did the Nazis actually take their subs and turn them into something else?
well, but Sam, the other thing to think of, right, is and the military might be an example of this. Sometimes they use older technologies because they fit a specific application, and so even if something is kind of outdated by the way that we look at it, maybe this UFO has some limitations that a regular, but yeah, that's a tough question. Let me go to Gene. Gene, you had something to talk about? Let's see if we can get his equipment working. Oh, it looks like he might still be having mic issues. There we go. I can barely hear you.
My mic and webcam aren't working, so I'm kind of stuck with the chat line. I was
Okay.
wondering if there's any symposiums dedicated to investigating frame dragging as a means of achieving work.
I don't think there are, but that's something that we can cover here. I can add that to the list. I mean, that's a topic that's come up from time to time. I think that we've touched on it, but I don't think there's anything that's dedicated to frame dragging.
The reason I asked that is because it was just a couple of months ago that NASA confirmed Einstein's theory about frame dragging using the satellites in orbit.
Okay. Yeah. Well, yeah, I mean, that's something that we can definitely add. I know gravitomagnetic frame dragging has been something that we've talked about as well in the past. So I go to Will next. Will, you have something?
Well, kind of just a general question. David Hatcher Childress, a good friend of mine, has written several books on Vimana. And from what I've read from his work, it appears that these Vimana things seem to last forever. They don't age, they don't decay like modern technology that we develop. So when I think of like aircraft, for example, I mean, there's a few 100 million scattered across our planet today. So I'm just kind of curious if the Vimanas don't age, they last forever. Where are they?
Yeah, that's an interesting question.
In the ocean.
In the ocean? There you go.
A hollow moon.
I think everything ages, right? Maybe that's the other part of it is, I mean, maybe past a certain point, maybe they don't age normally, but even so, these things are so old that who could tell? Maybe
It's just a question I wanted to put out there. That's all.
Yeah, no, that
Not
makes sense.
exactly my expertise. So.
Yeah, well, and you're working on a presentation for a couple of weeks from now, right? So
Yes, I am.
yeah, and that'll be exciting. Yeah, that was the superconductors and MHD, if I remember right.
Oh, that's right.
Yeah, no, I'm looking forward to that. So we're doing pretty good. Well, everybody, I should apologize for being for the gap here, for being so slow. We've got about half an hour left. Ned, you had something to share, sir?
Yeah, thanks, Tim. Appreciate the opportunity. Hi, I wanted to find out and just ask maybe you specifically and the wider audience, of course. I think you've had some experience with some ionic levitation and using electricity to that. Do you know or what are anyone's opinions on the limitations of using electricity as an electric force for electric propulsion and why that is not basically continuing? I'm thinking of the work that
Townsend Brown for
Thomas.
that one.
Exactly, I'm exactly referring to that, and I'm curious now in this age of electrification and everyone going electric, why hasn't that been more proliferated?
Yeah, I mean, and that's the area that I kind of worked in. So I think there are a bunch of different factors. The triangle shaped lifters, right? I don't know, that way I can see myself on the screen. That triangle shaped lifter is I think that was probably the biggest and most well known. You know, I was building those. Everybody was building those a few years ago, and the problem that we had with those was the efficiency. You know, it was we could get thrust. We had no problem getting thrust. You know, we had no problem getting power. The problem was the efficiency of it. And when you start to scale that up to something that would be like an aircraft, it was a real challenge. Now things are different now, right? I mean, the technology's progressed, so there might be some new opportunities there for people to experiment with. So the lifters, though, definitely had an airflow. And then over on this side of things, you have the true Biefeld-Brown effect. And you've got stuff like Hector Serrano's Gravitech, you know, and a lot of different variations on that are trying to do this pure effect as opposed to the ion wind one. The challenge that I've seen is getting results in a vacuum, and it becomes this, it's almost like this he said, she said, right? Where one person said, well, we saw something, the other person said no, you know. So I don't know, that's definitely one of the challenges there with it.
Have you ever have you ever been able to raise to how high of a voltage can you get above 150,000 volts?
Yeah.
or what have you had the experience with?
I think the highest I ever used was like 120 thou. Now that being said, one of the things I found was I had a custom power supply from Information Unlimited that I spent a lot of money on. And it was, I believe, I had a 100,000 volt one and a 50,000 volt one. I think I blew out the 100K. And the 50K one was what I used most of the time, and it worked great. But one of the things that I found was with lifters or any kind of ion wind device, so you have the wire above the foil, right? You have a really narrow wire. I used 50 gauge stainless steel wire. And the reason was the ion transfer on that was maximized. And then with the foil underneath it, we just use regular aluminum foil. We'd loop it over the top and just make sure there weren't sharp edges to it. But what I found was when I turned the power supply on, it worked great. We had lots of thrust, but that wire foil combination with like an inch of air gap or less, it creates kind of a natural resistance in the circuit, right? So I went into the power supply, and most power supplies have this, and I bypassed the output resistor, and so that lets the voltage float. So instead of having it forced to 50K, the lifter would actually set its own voltage when it was running. And we did some measurements with that, and depending on stuff like air temperature and humidity and a lot of different factors, you could see that voltage fluctuate a little bit. So,
wow, that's fantastic. Thank you.
Oh yeah, absolutely. Yeah, those were a lot of fun. And for me, the largest one that I built was 9 feet on a side. So it was literally 9 feet, a 9 foot long lifter, and it had a bunch of cells inside of it. And then I would do kind of this bed spring type winding with the Corona wire. And I got that to fly, but it was so big that it was just unwieldy. The one that I did most of the time, there's photos of it all over the place, was 4 feet on a side. And it also had this bed spring style winding arrangement with lots of cells inside of it. But I think I had mine up to 8 or 10 feet high. You know, so, and I never had any real issues with it.
So what do you think is the limiting factor of in you? What is the one single challenge that's preventing this from being scaled up, or what would you change to make it scalable?
Well, again,
What would you need?
yeah, I mean, the efficiency was part of it, right? So part of it was the literally it's just the ROI on the energy that you're putting into it, because you've got to step that up. You have to step it up to a high voltage, and but you still need current too, right? Because with the ion part of it, that was definitely part of it.
I'm sorry, but have you ever considered nuclear to electric conversion and how that scales?
Yeah, that was beyond my means, sir.
Okay. All right. No,
that was way beyond me. And at the time, actually, when I was building, there was one person online who was able to get a power pack working, like I think it was NiCad. They were barely able to get it working. But see, today's batteries should work a lot better. So
thanks, Tim. Appreciate that.
Oh, sure thing, Ned. Michael, do you have something, sir?
Yeah, there was a question about frame dragging from, I think, Gene. So I'd like to share the screen and provide an example of that.
Yeah, go for it.
Okay.
I'm all ears.
Okay, so can you guys see this?
There we go. Yep. Yeah, okay. And we've got about 20 minutes at the outside if it takes that long. So
it's not going to take that long. So what we have here is an image. So first let me show you what the apparatus looks like. Here's a cross-sectional image of the device. So this device uses it's like your hard disk in your computer hard drive, and this is a cross-sectional view of the device, and this little thing that looks like a sled, that's called a slider. And then sitting on the tip of this thing is this little sensor. It's a special resistor that's sensitive to changes in magnetic fields, the direction of the magnetic field. It's called a giant magnetoresistor, not because it's big, but because it's real sensitive to the magnetic field changes. Now on the back of the slider, there's this green thing, and what that is that's a little piezoelectric crystal. And so basically the disk is spinning counterclockwise, and as the little nano bump goes under the disk, the bump is the magnetic signal that's coming back from the GMR head, and over here on the left is the piezoelectric signal. So if you see over here, this is Earth's gravity. The disk is spinning, and when the nano bump goes under it, it pulls it down, and it's like it's like a spring, and it's undampened spring force essentially. So what happens is, that's the apparatus. That's how it works. The disk is turning pretty fast. It's spinning about 27 miles an hour. So now going back to this first signal, what I'm showing here is how the gravitational frame dragging works. Is these like little pulses here, those are magnetic induction, and they're produced as the edge of the nanobump goes over it, the magnetic field direction changes 90 degrees. So you'll see the first pulse here is going up, and the second pulse is going down. That's as each edge goes by. Now the gravitational induction signal is this big broad signal. That's what's called gravitomagnetism. It's produced by the presence of mass moving in the universe. Now, the other thing that's cool about gravitomagnetism is there's anti-gravitational force that's produced by the absence of matter. Now, here we have our same figure, and we're seeing this little nano pit we have. It's the same size approximately as our nano bump, 10 microns squared. And as that nano pit goes under the sensor, the piezoelectric crystal experiences a little push force. And you see it's like fully dampened. It's because it's pushing against gravity. And then you look at the GMR signal and you can see the electromagnetic pulse signals from the edge, but the gravitomagnetic signals go in the opposite direction because it's a push force. So so there's basically frame dragging. If you have the same volume, the frame dragging is the same amount. So basically, this infers there exists two different time frames, one for matter or the lack thereof, and another for electromagnetism. And so this is what frame dragging looks like. And that's some actual data. That's all. I just wanted to show that. Did you see?
Awesome. Thank you, Michael. I appreciate that. You know what?
Did that answer your question?
It did. It did actually. So, we have Nick Cook with us. Let me see if he would be interested in starting early. Nick, are you with us? And it could be that Nick is just waiting until the top of the hour. Well,
Yeah, I saw him, but
yeah,
he disappeared.
Yeah, let me go to Mikhail then. Mikhail, you had a question, or no, well, I guess we're not doing Q&A.
Yeah, I just had a question to Michael, sir. Sir, the paper you just showed us right now. We did a test in our lab about back in March 2020, I meant to say.
Oh.
Uh-oh.
I think yeah. I wonder if something might be going on with Zoom today. We had a bunch of folks with network issues.
Well, I got a hardwired connection.
I wonder if it might be something with the server, though.
Well, yeah. Well, he's on. He's talking. I can see him. What I would do is turn off your video, and that'll increase your bandwidth so we can hear your audio. Okay. Now talk.
So yeah, what I was saying is back in 2020 March, we did an experiment based on the gravity sphere. We spent about 4 years developing different kind of lifters, which Tim had done, and then we created a ball element.
I'm losing you.
I'm
Why don't
sorry.
Put it in the chat.
I'll
put it
in
the chat, and then we can all see it, and I can answer it for you better.
Sure.
Yeah, thanks, Michael. It's interesting what you said about hardwired. That does make sense when it's cutting in and out like that. A lot of times that is Wi-Fi. Mine is hardwired too, so I'm right there with you.
Yeah, no, I got what is it, RJ45 cable, and it's shielded.
Yeah, I know what you're.
So it means that you can't knock it out with ESD.
There you go. I'm running Cat 6 at home, which you can buy now. You can buy gigabit routers, Cat 6 cabling. You can get data center quality stuff at Best Buy. So why not?
Yeah, just get the shielded ones. That's all I'm saying, because it's less interference.
Well, again, Nick, let me see. Nick Cook is with us. Let me see if he wants to unmute. Okay, and I think maybe he's prepping his stuff, or he's not quite ready yet. Okay, does anybody else have anything to mention, or any questions or anything along those lines?
I was going to ask you earlier, but you moved on conversation-wise. Do I sound all right, or am I blowing everybody out?
No, you sound great, Thomas.
Okay, good deal. When you were talking about the lifter technology, did you try doing any stacking, like put the lifter components inside of a restrictor, kind of like you have in with these cowled fans, where basically they're inside of a tube?
Yeah, I know what you're talking about. I did try stacking on. So the problem was like the type of stacking I tried was if you can picture a series of lifters, right? Because we build these triangles, you do a triangle with a corona wire and then a triangle above it and a corona wire. I was able to get forward thrust with that, but obviously the problem is from the ion component of that. It's attracted to the foil above it as well as the foil below it. And so it negates a lot of that thrust. You do you get an overall net thrust, but it wasn't as great as I'd hoped.
Did
Yeah.
you have it surrounded though so that the airflow was trapped inside of the wind tunnel though? Or was it still open air on the outside edges of it?
I tried, I didn't try it with a stack design, but I did try Bernoulli enhancement on it. And it did work pretty well. I had some results with that. And what you're talking about is the Bernoulli enhancer. What I was going for, what I was attempting was, so, and again, this is all part of the problem was lifters, the scientific world likes to make lifters seem really clean cut, but they weren't, nothing about that was clean cut. And we had weird side effects and for instance, the inertial profile on those never really lined up with what it should have, and if I had the time, I've got photos or I have videos buried somewhere where there was a fellow in Belgium called Savoir. He did one by today's standards. It's like 320 by 240 video. It's tiny, but at the time, this is like 2001. It was good. And so what he did was he took a lifter and he put it on a gimbaling system and he used a fan to spin it, right? So nothing is touching it. And so he spins it. This fan is, it's kind of slow, but it starts spinning up to he gets it up to, I think not 20 or maybe about 20 RPM. It's going around, about that fast. And it was turned off. And the minute he turns it on, it slows down and stops. Even though it's being spun, right? So there's some kind of a weird inertial effect there. So the next experiment he did was he put this entire thing inside of an enclosure and he spun the enclosure with the fan, right? So the lifter is completely contained. The power supply, he used leads that could pivot, the top and bottom power wires that could pivot, right? And the same thing happened. So when they're operating, they tend to reject external inertial forces. And I noticed that as well. You could have you'd have a lifter flying and it would be tethered. If a strong wind came up, you could see that the lifter would actually try and reject the wind blowing it. And there's no great way to describe that, but it would also reject changes in orientation and axis and things like that.
Well, I'm wondering if you've compared this to like when you run an electrical charge through a liquid between two magnetic plates, it'll cause it to flow in one direction between the plates. And maybe considered, since air is considered to be a fluid, it's just a much lower density fluid than, say, water. Applying some of those, potential theories to it, which, I mean, I understand the issues with the unforeseen effects, considering you're working with a Brownian motion material that's basically whizzing around at 700 miles per hour, smacking off each other. So otherwise it wouldn't be a gas, it'd be a liquid. If you drop that speed down, it would end up glomming together and form a liquid. So
I mean there was they were I did 2 or 3 years of intense work with lifters there, and I did it for a while after that, but and then I was part of these enormous discussion groups, and I think if Rob Chambers is here, I know definitely Rob remembers those, Tony Robertson, he probably remembers those. Gary probably remembers, Gary Stevenson probably remembers them. There used to be these massive Yahoo groups and people would post these experiments to talk about what they were trying. And with the lifters, the thing that always troubled me was the ion wind is definitely a big part of what was going on with those. Absolutely. But it always felt like there was a lot more. And it's almost like the mainstream scientific view almost kind of swept that under the carpet. They're like, okay, it's ions, we're done, So
yeah, I was gonna say, I was thinking that
looks like you're sharing on accident, Thomas. Oh, that's
Really?
Michael. Okay.
Oh, I was gonna say that's not me.
Like rotation and
Here, I'll
mercury
stop
and
him.
magnetic fields and electromagnetics.
Well, the other thing I was thinking too, though, is that if you look at high voltage potential, there are these stories about ball lightning going right through solid objects, and then when it dissipated, it would drop solid mass and liquids that it carried through. Yet there's no damage to the solid object that went through. If that,
Tunneling.
if that works that way, then that means there's probably something going on where it's forcing all the particles that are in the atoms, because most of an atom
Because
is
it's
just
a
a vacuum.
plasma ball. My dad actually saw that
It's
happen.
tunneling. It's tunneling through
Saskatchewan.
the barrier. That's
Well,
all.
no,
It's-
listen. The majority of an atom, though, is a vacuum.
Yeah, yeah.
The particles that make up the solid mass of an atom are very small, very minute. So if you organize them properly, they will pass right by each other the way like airplanes flying by each other where there's a gap in between each one. Except we're talking about an airplane that has the room of almost an entire planet to fly by another airplane.
You mean if
But
the
they're
fields
moving
don't interact?
Right, but they're moving so fast that basically normally they bounce against each other because there's enough time for them to come into contact with each other in relation to the speed that they're trying to pass through each other. But if you force them all into a specific orientation with high voltage, that could potentially cause an alignment to where they can pass through each other's vacuum areas. The solids of each of the material can pass through each other's vacuum without interacting. And maybe that has something to do with the ion lifter technology too, because you are working with high voltage and it might be forcing that alignment. The same thing
Got
applies,
it with
I
the
think,
high
to
voltage exciting
Yeah.
it into the plasma state. It's
Well-
the fact that you have to have it, that you have to see plasma as the fourth state of matter. High voltage connects like your single monoatomic atoms into that plasma state, which then interacts with the higher dimension of what the ancients called ether. Now we call dark antimatter, whatever, but it's the higher dimensional energy transfer back in and out into the third state solid, second state liquid,
so you're
first
saying
state
it's
gas.
resisting the inertial
It's
effect
plas-
because it's
Yeah.
interacting with
Well-
the solid mass we call dark matter that's so low energy state, it's all stable. So it's wanting to lock to it and stop moving, like it's acting like it's stuck in a solid instead of in an empty
It's
void the way this
plasma.
normally is.
It's plasma state
Oh.
and resonance. You need
What-
both the resonance and the plasma state to create the tunneling effect, where you create a standing wave where you can go through the barrier without anything. being affected.
The other thing to keep in mind is you definitely have now with the ion part of this, you have some coupling issues with the lifters, and that was one of the reasons that we got into Bernoulli effect enhancement, because so you've got these planar sheets of air flowing, right? And the ions, I don't remember how fast they're traveling, but it's thousands of miles per hour, if not faster, because they're basically. I tried both positive and negative voltage. So again, you could have electrons, which are, moving through the air, taking air molecules with them, or you could be stealing electrons from air molecules, which then promptly go to the ground, right? So
Right,
you
a
can,
push-pull method.
yeah, there were, we tried both polarities with it. What I found was, not surprisingly, if you're adding electrons to air molecules, they will hop air molecules. But if you're stealing them, right, then it's less likely to, you don't have an excess of electrons to hop. So the same amount of voltage and current actually produces more force, right? Because you're working with ionized air instead of trying to basically charge the air and then hoping it goes where it's supposed to. So
Right.
now
I was
in
gonna
charge
say
of
one other effect I should mention, and I wanted to say this earlier. If you notice, you can run the same amount of wattage through a very small wire if it's running at a high voltage. And one of the things I thought that might be accounting for that is because at the higher voltage, all of the atoms in the wire are being forced into alignment so that they act more like materials at extremely low temperatures where they drop and all kind of stick together, so the electrons can just shoot straight through like through a Newton's cradle, as opposed to it, all being disjointed, and it has to go through the resistance of jumping from one electron orbit to the next where there's a gap. So
could
I'm
be.
wondering if that applies to some of this too, with the running at a higher voltage like that.
It could be. I mean, yeah, I can't give you a good answer. It's it is an intriguing area. There's a lot there. And I think there's a lot there still waiting to be discovered. That the challenge was getting the efficiency of these things up. You know what? So one thing that it was kind of people were getting excited about was at the time, not graphene, but they were looking at basically nanofibers to emit these things. And the idea was you put a bunch of these nanofibers, almost like steel wool, you know, and maybe you could emit these ions, you could lower the voltage down to reasonable temperatures and emit tons of them. But one of the problems in general is when you've got that many emitters that close to each other, the electric fields tend to smooth out. And so one of the problems we ran into was you want to have lots of emitters, but you don't want to have them, electrically speaking, you don't want to have them form like a solid field. You really want them to be these narrow filaments. So
Right.
well, let me see.
I think we're just about on the hour.
Yeah. I was going to say is
the lifter thing. I guess I'll just quickly say that the two most important keys to it are you want high number of neutral air impacts. So you want your ions that are being accelerated between your collector and your emitter grid to impact as many neutral air molecules as possible. So you can get that maximum dielectric entrainment of neutral air density. And the second thing is the cross-sectional area of the wire is extremely important. The smaller the cross-section of the individual conductors of the wire, the higher the efficiency, because the electrons can easily leap off of those emitters or they can easily be collected by them. And so it's much more efficient to produce ions with these small cross-sections. And there's seldom a conductor ever discovered by mankind that's thinner than a single carbon nanotube. So coating a already thin conductor in a barrage of nanotubes to get what you would call kind of a fuzzy wire is one of the most effective ways to both collect ions from the atmosphere, as Ion Power Group has done, and they're able to power, several kilowatts of machines with collected ion power from the upper atmosphere. And then it's also one of the most effective ways to produce ions. So these are definitely some fundamental principles as far as the ion thrust engines go. And the most effective is actually to produce the ions within an enclosed chamber and inject them between your two potential grids so that you're not producing them with the corona wire. And this allows you to get a much higher ion density into that airstream and get a much higher neutral air impact than you could possibly get in terms of accelerating at the same voltage that you're producing ions at.
There you go.
But it's like
Something else I've noticed too is nobody is using basic aviation physics where they're not using any nozzles to make sure that the airflow that's coming out is not losing lifting or thrust potential by basically nozzling it. Instead, it's just left to expand in all directions, which anything that's not coming straight down out of the lifter in the direction that you want to push the lifter in the opposite direction is going to have a very limited amount of effect on its forward motion.
Yeah. Yeah, and I could speak to that, but I think we're just about at the top of the hour. So let's table that until another session. Let me see if Nick is with us. Nick Cook, sir. There we go.
I am here.
Yeah. Thank you, sir. Well, let me do this. Let me do an intro first. A man who needs no introduction, but I need to do one nonetheless.